All right, just going, and we're going to go through this very, very quickly. From chapter 1, 3 undefined terms. Anybody remember the 3 undefined terms?
Point, line,
Point, lines,
ray. No.
planes.
Yeah.
Points, lines, and planes. 3 undefined terms in geometry. So make sure you know those. Make sure you know the geometrical shapes and use the symbols. So segments, angles, make sure you use the symbols on everything where you're supposed to use them. I had somebody on one of the tests, I was grading it, and they had this. Using segment addition postulate. Is that right? No. These are what? Angle symbols. I'm not sure why they stuck the angle symbols in there when you're dealing with segments. So make sure you don't use the wrong symbols. Make sure you use all the correct symbols. Know and use basic terms of geometry, collinear, coplanar, midpoint. Know all those. Segment addition, we've been talking about it a bunch, so make sure you know that. Number 5 here, distance formula. Make sure you know how to use the distance formula. You might want to circle distance formula, maybe put an asterisk beside it. Guarantee there's several problems on there about distance formula. So make sure you know how to use the distance formula. Make sure you bring a calculator. Chapter 2, name and classify angles. Make sure, again, how many letters to name an angle? 3 letters. Make sure you're using 3 letters to name your angles, unless they give you something like angle 1, like we were just doing. Know all the stuff about each one of these. What do you know about vertical angles? Vertical angles are congruent. What do you know about complementary angles?
They add up to 90.
Add up to 90 degrees. How about supplementary angles?
180.
Be able to find the perimeter or circumference area of any 2-dimensional shapes. Perimeter is, again, what? How do you find the perimeter of a shape?
Add up the sides.
Add up all the sides. Circumference is for a circle area. Make sure you know those formulas. Some of the formulas. What's the formula for area of a rectangle? Length times width, or base times height. Don't make that harder than it is. That's something you should have already known. Reflections, rotations, translations, be able to do those. Width. Remember, translations, those are just slides. Reflections, you're reflecting over the X or the Y axes. Remember, for reflections, just count the spaces and you should be able to do it. Rotations, the ones that you need. That chart that we had, I know Jackson's got all those rules memorized, but probably the rest of you don't, because he's so much smarter than everybody else. Surface area and volumes. Again, make sure we had in your notes, we had all the formulas. So make sure you know where that formula sheet is. Not sure what that just did. Skipped way up on me, didn't it?
Yeah.
Man, your board is all messed up.
It works.
It works.
Nets and modeling. Remember, when we're finding surface area, you're just going to find the area of each face and then add them all up. So you're going to use a net and be able to model stuff in real life. Like if I was to say our room here, what shape are we using?
Or rectangular prism.
Rectangular prism. All right, so be able to do that. If I said a tree, what shape would we be using? Cylinder. Chapter 3 here, we just got done going over all this, so I'm going to go over it very quickly. Remember, with a counter example, you give one specific example. Inductive reasoning. What's one word for inductive reasoning? Patterns, how about deductive reasoning?
Reasons.
Rules. A negation, remember a negation? It's just something like this, you make it sort of the opposite. I don't like saying opposite, but I think on the chapter 3 test it said something like, it is sunny. What's the negation of that?
It is not sunny.
It is not sunny. Don't make that harder than it is. The two laws, know those. Properties, reflexive. Remember, reflexive says anything equals itself. Well, when I graded this stuff for all my classes, converse, inverse, and contrapositive. I'd hate to be some of your guys' English teachers, because I mean, it was. Some people are just good idiots. Not very hard workers. I'm trying to think of a nice way to say it, because our thing said if a quadrilateral is a square, then it is a rectangle, right? And you can abbreviate some of it, and I don't have any problem with abbreviating some of it like I just did there. But I had people say stuff like, for the converse, what's the converse do?
Flips it, yeah.
It switches it, right? Just switches it. So I had people write, if rectangles, then square. And simplify it down that much. That's too much. All right? So what's the inverse do?
Negates it.
Negates both parts. So it'd say if a quadrilateral is not a square, then it is not a rectangle. And what's the contrapositive do?
If a quadrilateral is not a rectangle, then it's not a square. I think that's good.
I had some people that did it really well. Not against all of you, just some of them really hard to read. Algebraic 2-column proofs. Make sure you know how to do those. Remember, for those properties, it's like addition, property of equality. You gotta have that on the end. And I know you'll find this hard to believe, but I had several people just skip right over the algebraic proof.
Really nice, the easiest thing.
That's what I thought too, but that's why I stuck it on there. Be able to do the geometric 2-column proofs. And then we just talked about the angles related to parallel lines and a transversal. On the review packet. On the review packet, any questions you want to see worked off the review packet? They all easy? 10. You have to help me out and read me those numbers. So we got a box, right?
Yeah.
One second, let me get my thing set up here. Number 10. Got our box here. My box sort of look like your guys's. And 12 inches. What do they tell us over here?
8.
Here?
6.
They want us to find the surface area and the volume. Which one do you want to find first? Which one's easier?
The surface area, or no, volume.
Volume's easier,
They're both
right?
easier.
So you want to do it first. For a rectangular prism, to find the volume, what's the formula for a volume?
Length times width times height.
Just length times width times height. What's the length this time?
12.
Does it matter?
No, doesn't matter.
It makes no difference which one's which. So 12 times what?
8 times 6.
Times 6. Ignore that.
That equals 576.
576, anybody agree with that? What's our units?
Inches cubed.
Remember, for volume, it's always cubic inches, so inches to the third power. So that's the answer for the volume. Surface area. There is a formula to find the surface area, but we probably don't want to use it because it's a whole lot easier to just break this up into each face. How many faces does a box have?
6.
So we just do something like this. All of them are what shapes? Rectangles. Now, they could be squares, but we don't know that for sure, right? Well, actually, we do know if they're not because of that. So let's do the front face here. What's the dimensions on that front face?
12 times 6.
12 by 6. How about the back face? 12 by 6. Those two are going to be the same. How about this end face down here?
8 by 6.
8 by 6. Everybody agree with her on that? How about the other end?
8 by 6.
8 by 6. And how about the bottom?
12 by 8.
12 by 8. And the top then?
12 by 8.
What do you got to do with each one of those?
Multiply. And then add.
Somebody tell me what's the area of this box here, or this rectangle?
72.
72. How about this one?
72.
This one?
48.
This one?
48.
This one?
96.
This one?
96.
And what are you going to do with all those?
Yeah, about.
Add them all up. What's it come out to?
432 inches.
Remember, square units, because you're figuring out how many little squares does it take to cover that. So for volume, you're seeing how much will fit inside the box. For surface area, you're seeing how much paint would it take if I'm going to paint all the faces on this box. Don't forget your units. Question like this on the test probably worth like 6 points. You show me this, you get a point. Show me the answer, 576, you get a point. Show me the units, the correct units, you get a point. Show me this work, you get a point. Show me the 432, you get a point. Inches squared, you get a point. Other questions?
21.
21. We've done this probably.
We've done it a bunch of times, but somehow I got it wrong on the test. So I want to see it again.
I write all those right. Now, notice, what do you know about these two lines?
There.
Are they parallel to each other?
No, it doesn't
They
say.
didn't tell us that, right? So we did this problem before we knew about the parallel. If they would tell us that they are parallel, and we're trying to prove that angle 2 is the same as angle 4, it'd take 2 steps.
Give it and then the
Since the lines are parallel, these two angles have to be congruent, and we'd have a reason for that. We don't have it yet.
Can we put this in her room?
No, lay it on my chair over there. Or, well, actually, you can leave it lay right there on my desk. I'll just pick it up and carry it back there. So we don't know that they're parallel, but what do we know about angle 1 and angle 2?
That they're over here. No, they're vertical.
The vertical angles, so they have to be
Congruent.
congruent. What do we know about 3 and 4?
They're vertical.
They're vertical. What'd they tell us? Anything?
They just said that 1 and it's congruent to angle 3.
So let's mark angle 1, congruent to angle 3, so we know that. Now you told me 1 was also congruent to 2, so we can mark it with 1 arc. What's that tell me about 2 and 3 then?
They're congruent.
They're congruent also. What do we know about 3 and 4?
They're congruent.
So that we can mark it. Well, if 1's congruent to 2 two's congruent to three, three's congruent to four, what's that tell us about two and four? They're congruent. Also, what property are we probably using in there somewhere? If we took out one thing, vertical angles, that's one of them.
Substitution.
Substitution. What's our first statement gonna be?
Angle one is congruent to angle three.
How do we know that?
Given.
That was all the given, what'd you tell me after that?
Angle one is vertical to angle two.
So angle one is congruent to angle two, right? And we knew that because vertical
Angles are.
angles are congruent. Now look at what we have in one and two. What can you tell me from that? You know, one's the same as three, one's the same as two. What can you tell me from there? Two is the same as three. What did you use there? Substitution property. Is that what we were trying to prove? So now, what else did we know?
That two and four are congruent.
Now we need something before that. What else did you know from the picture?
It's a linear pair.
Not a linear pair. Remember, a linear pair would be like this angle and this angle, right? What do we know about three and four? How come they're congruent?
The vertical angles are congruent.
Vertical angles are congruent. Now look at what you have in these two. Angle two is the same as angle three same as angle four. So you got angle three in both of these, don't you? So what do you know about these two? They gotta be the same. So angle two is congruent to angle four. Substitution property. Other questions?
What about 16?
16.
Yeah.
Problem 16. Yeah, I think this one's on there too, so hopefully this will help. Because this deals with the parallel lines.
Oh, I see it now. I see the little lines.
So on problem 16, if I just draw this, watch closely, because this is a very, very easy problem. Again, I'm not taking it off there. What do we know about this line and this line? Those are parallel. This is called a transversal. And this is angle one, that's angle two, and Clayton was right. What do they form? The Z. So what do we know about those two angles? They're gonna end up being congruent to each other.
Oh, that's easy.
And angle, what did they tell us? Angle two is 55 degrees. So what's the measure of angle one?
55 degrees.
So measure of angle one is 55 degrees. That's our answer. Evie, too hard? Now the bad thing is, as soon as I start putting in the lighthouse, you got your lighthouse out here and you got a boat out here. I can't do nothing about old Clayton over there dreaming, and you know he's not thinking about parallel lines. He's thinking about, I wonder what those people on that boat are doing. I wonder if there's somebody standing up in the top of the lighthouse right now. I wonder what's going on. I wonder if the person in the lighthouse is flashing the light at him or something, trying to mess with him, instead of thinking about the angles.
Oh, I had a question on 18. It's like a really easy problem, but there's not a number for the, what you call it, the vertex.
Oh, yeah. Yeah. I thought I fixed it. So on 18, right there in the middle,
Yeah.
where everything comes together.
You need it for everything.
Yeah, you need it for everything. Put, what do I gotta hand it to you? Put an L in there. So, for that, put an L in there on that. Can't believe I forgot that. Need to write that down. I fixed it, I thought I must have printed off the one I didn't fix. 18. Review packet. L. Should take all my other classes. All right, we got about a little 25 minutes. What I'm gonna do, questions, terms, anything that you want to know the definition of before this vocab test.
I think so.
Nothing?
Oh, that thing's so good.
That's all right.
A complementary angle is the 180.
No, it's 90.
Two angles that add up to 90 degrees.
It is every
That's against me.
What else?
What does that mean?
So two angles that add up to 90 degrees would be like, for 18, it would be like.
I think there's a right angle in this, and then there it
Yeah.
is. So it'd be that angle and that angle.
Okay.
And that's complementary.
What else?
Two angles that make a straight angle is a linear pair, right?
Two angles that,
Because there's like 3 of them, but they're slightly different.
so two angles that together make a straight angle, like angle 1 and angle 2 there, linear pair. Now, these two angles can also be called what to each other?
Adjacent.
They're adjacent, they're also supplementary. But if I wanted supplementary, I'd say these two angles,
just measures that up.
they add up to 180.
What is 3 collinear points? Is that just like 3 points
On
a
the same
plane?
line.
On the same line, so,
Coplanar is on the same plane.
so those 3 points are collinear.
Okay.
Now, those 3 points are also coplanar because they're all on the whiteboard,
Yeah,
but these 3 points
they're also
are coplanar, but they're not
collinear.
collinear.
Okay, so for this, or I do like,
Just one point in each blank. So, point B, point L, whatever you said.
can I just write the letter?
Yeah. Other questions? We ready for this vocab?
Yeah.
So,
Yeah?